screencast is going to focus on finding points or point of intersection between parabolas, between a circle and a line, and between a parabola and a line. So let's go ahead and get started here. So we're looking at two parabolas, and we know that because we have a degree of 2, and that's the highest degree. So we know these are both quadratic. So basically, we're trying to find the point of intersection. That's what I'm telling you verbally. You would say this on the test, find the point of intersection. So we need to figure out if they intersect at all, if they intersect once, or if they intersect twice. So basically what we're going to do is we're going to substitute one of the equations for the y in the other. So I'm going to rewrite this as 3x squared minus 30x plus 69. And then for this y, I'm going to substitute in this because this is equal to y as well, so we can swap it out. Okay. Alright, so now that I've set this up, I can go ahead and start moving things over. And actually what I want to do is I want to get everything on one side. So I'm going to add 2x squared. I'm going to subtract 16x from both sides because I'm trying to make this right side 0. And I'm going to add 27. Okay, so I end up with 5x squared minus 46x plus 96 equals 0. So if I wanted to, I could go ahead and try to factor this, but I'm not going to do that. I'm going to just plug this into the quadratic formula and find my x values. So x equals negative b, which is negative 46, plus or minus the square root of 46 squared minus 4 times a times c divided by 2a. So I'm just going to grab my calculator and plug this in. Give me 1 second. And then we'll have our x values ready to go. Alright, so in your Casios, I'd recommend you using the fraction bar, and that way you don't have to worry about making sure you divide everything correctly, you know, with parentheses and everything. So one of my values is x equals 6. So I'm going to go ahead and jot that down. I'm going to do that over here. X equals 6. And the other value is probably something not so nice. Not too bad. X equals 3.2. Or its fraction equivalent. So what I do know now is that I have the x coordinates, so I need to plug these back in to get the y coordinates. So I'm going to go back up to one of the original equations, and I'm going to go ahead and substitute 6 in for x and see what it spits out. So I'm going to write this in a different color so you can see what I'm going to enter in my calculator. I'm going to use the top equation just because, although it doesn't really matter which equation you use. So 6 squared is 36. Minus 30 times 6 plus 69. So when I put this into my calculator, I get negative 3. So when x is 6, y is negative 3, so that's one of my coordinates. Okay, so I'm going to just jot this down over here. I have 6 and, oops, I said negative 3 and I wrote a positive. Isn't that slick? Okay, and I'm going to do the same thing, except instead of substituting 6 in, I'm going to now do 3.2. And when I do that, I get y equaling 3.72 positive. So my points of intersection are 3.2, 3.72, and 6 and negative 3. So let me show you the graph of this. And of course, if I were doing this on a test and I wasn't strapped for time because of the internet, I would plug both of those in and make sure that they are correct. So here's my graph. So I just put this into a graphing program. So if I look, I have an intersection point. So I wanted to show you what these look like. I have an intersection point here and here. So I know that I have two positive values, and this looks about 3.2 and 3.72. About, it's less than 4 on both sides. Then I have right on 6, and I'm in the negative area, so -3. So those are where those two graphs intersect. All right, so we're trying to figure out where this parabola and this line intersect. So, or if they even do intersect. So basically, we have this parabola equal to y. We have this solved in terms of y, so I am just going to substitute x plus 2 for y, like this. All right, so now I need to kind of just distribute this or FOIL this so that I have everything together. So I end up with x squared, 3x minus x is 2x minus 3 equals x plus 2. And now I'm going to go ahead and distribute the 4. So end up with 4x squared plus 8x minus 12 equals x plus 2. So since we're going to be solving for x, we need to get everything on one side of the equation. So I'm going to go ahead and subtract x and 2 from both sides. So I end up with 4x squared plus 7x minus 14 equals 0. So at this point, I could use the quadratic formula, or I could factor this. So, I think I'm going to have to use the quadratic formula here. So I'm going to say x equals -7 plus or minus the square root of b squared, so that's 7 squared, which is 49, minus 4 times a times c, all divided by 2 times 4, which is 8. So I end up with -7 plus or minus 49 plus 16 times 14. So let's see. That is 224 divided by 8. So we end up with -7 plus or minus 49 plus 224, which is 273, which is not a perfect square, divided by 8. So I'm going to do something that you probably wouldn't do on the Cambridge exam because it'd give you better numbers than this, but I'm going to go ahead and round this answer. So -7 plus the square root of 273 divided by 8 gives me about, using approximately, 1.190. And, okay, Audrey really likes my graphing calculator. She's making this very difficult for me. Alright, 273 divided by 8. So, and -2.940, about. So now I'm going to go ahead and come up to my original equation, and I'm going to choose one of these equations to plug this back into. I think this is a pretty much no-brainer. 1x in this equation, 2 here, so I'm going to plug into this one. So y equals x minus 2. So y equals x minus 2. So basically, I'm going to go ahead and start down here since this is the number I've left in my calculator. So I end up with -4.94 for y, and 9 minus 2, and -0.81. Okay, so my coordinates are 1.19 and -0.81 and -2.94 and -4.94, and I should plug these back in to make sure that they work in the other equation as well. So I would do that if I were not doing a screencast and trying to keep the time short. All right, so that is also, I hope these helped you prepare for the exam.